The molecule is the smallest unit of a substance that shows all the chemical properties of that substance. A molecule is a group of atoms that are bound tightly together by strong chemical bonds called covalent bonds. Every molecule has a definite size. If a molecule is broken up into its atoms or into smaller groups of atoms by chemical processes, these pieces will not behave like the original molecule. A molecule can contain atoms of the same element or atoms of different elements. A substance made up of molecules that include two or more different chemical elements is called a molecular compound. An example of a molecular compound is water. Water is made of molecules that contain two hydrogen atoms and one oxygen atom. Molecules are compounds made up of specific combinations of atoms. Familiar substances may theoretically be divided into single molecules, as modeled here, but no further. Like a strict recipe in which atoms are the ingredients, each molecule has a chemical formula. If any ingredients are subtracted or changed, the molecule becomes something completely different. Scientists study molecules and their structures so they can better understand why substances behave the way they do. For example, molecular structure helps explain why water boils at a high temperature. Scientists and manufacturers also use their knowledge of molecules and molecular structures to make substances with desirable properties. Plastics, for instance, are laboratory-made substances that consist of enormous molecules containing thousands of atoms. By manipulating the molecular structure of plastics, chemists have created materials that stretch better, resist fading, or can be used in microwave ovens without melting. Similarly, pharmaceutical chemists use their knowledge of molecular structure to develop new drugs that more effectively ease pain or fight disease. The discovery of the structure of deoxyribonucleic acid, DNA, the molecule that contains the genetic blueprint for living organisms, opened the door to tremendous advances in medicine and industry. Knowledge of the structure of DNA has enabled physicians to understand and treat certain genetic diseases. Moreover, by manipulating DNA structure, scientists have been able to modify or genetically engineer organisms, creating, for example, bacteria that produce valuable drugs. Although much of our world is composed of molecules, not all substances are molecular. As we will discuss later, metals do not consist of molecules, nor do ionic compounds, which are crystalline substances, such as common table salt. The atoms in metals and ionic compounds form different arrangements from those of molecular structures. Molecular formulas are a shorthand way of describing molecules and compounds. Chemists use formulas to talk and write about molecules and to indicate how molecules behave in chemical reactions. The molecular formula indicates in special notation which elements make up the molecule and how many atoms are needed for each element. Understanding these formulas is the first step toward understanding the language of chemistry.